Today's Module 2, Lesson 5. We will connect models and the distributive property to partial products of the standard algorithm without renaming. So we're really going to focus on using those models to help us understand and organize our information so that we can do our multiplication in the easiest way possible using what we already know and the standard algorithm. Take a moment to write your target in your journal in your own words. So when we're multiplying multi-digit numbers, we want to try and make these as simple as we can. So it might require us to break these down a little bit, but we want to really think about what it's asking or what it's telling us. And it's telling us that we have 23 groups of 31, or we have 23 31s total. So if I wanted to do this mentally, I might break down how many groups we have so that it's simpler for me to compute mentally. And since I know about multiplying by multiples of 10, then I would go ahead and take my two 10s and make 20 groups of 31, and then my 3 leftover groups of 31, and then I could add those together. That would help me multiply these out mentally and somewhat quickly. Because they are some large numbers, so we want to make sure that we are breaking them down and using our strategies. So if I look here, I can kind of ignore my power of 10 for a moment. I'll come back to it at the end, and 2 groups of 31 would be 62. Now this is where I can insert my power of 10 and put the 0 at the end. Keep in mind, I'm not just adding a 0 at the end, I'm adding in the power of 10 from the 20 groups of 31. If I just added a 0, my 62 would remain 62. And then I want to take a look at those 3 leftover 31s, those 3 leftover groups of 31, and that would give me 93. So to find out the product of 23 and 31, I'd have to find the sum of 620 and 93. And that would be 3 1s, 11 10s, which would carry over to 100, and 700s. So I should be looking for 713. But our target wants us to use models because models do help us organize the information, break it down into easy to compute sections, and so we want to be sure we're using that strategy as well. Here's one strategy you could use, although even it could be written a different way. Your numbers don't have to be split this way. If you wanted to, you could have put the 23 at the top, and you could have split up the 31. Because either way, you're looking for 23 31s. However you decide to break down those numbers is going to be totally fine, and whatever's easiest for you to calculate. So we're just going to stick with this version for now, but if you wanted to switch it up, you could as well. So again, we'll have 3 groups of 31. They did a lot like we did up at the top. That would be 93. And then 20 groups of 31 is still, we're going to do that 2 times 31 for the 2 10s, which would be 62, and then add in that power of 10, not just a 0. So now we have 620. Just like we did before, and 93 like we did before. When we add those up, again, make sure that you're lining up your values, so your place values, and adding those. Oh, sorry about that. And we do get 713. Now, because we're 5th graders, because we speak the universal language of mathematics, and we want to be able to solve in all ways, we want to use the standard algorithm as well. So when we're using standard algorithm, we'll take our 23 and our 31, and we're going to start with our 1's digit of our second factor first. So we'll do 1 times 3 is 3, 1 times 2 is 2, and now we're ready to look at our 10's value of our second factor. So because this is the 10's, we can go ahead and put our 0 here. And now we're starting in the 10's spot here at in our standard algorithm. So now we'll take a look at our 3 10's times those 3 in the 23, which would give us 9. and our 3 tens here times the 2, which would give us 6. And now we're going to add those values together. So we have 3, 9 and 2 is 11, 1 and 6 is 7. So you can see if we broke it down and did our computation without a model, we got 713. With the model, we got 713. And with standard algorithm, we got 713. Remember we said you could do a different area model or a different model altogether. You could have flip-flopped the numbers on the model. It's totally fine. The purpose of the model is to organize your information. And then if you also wanted to, you could break down each one of the values and do your 4 square here. And you can see that we did 20 times 1, which is our 20 here in the first square. 3 times 1 is 3. Also notice that these are 20 is in tens, so we make sure our answer has 20 is in our tens. Here we have 2 powers of 10 for our 20 and our 30, so our answer 600 has 2 powers of 30. And still, if you're adding that 23 and 690, we're still going to get our answer of 713, just like we did the previous 3 times. So let's try it again, this time with a larger factor of 343 21s, or 343 groups of 21. So let's think of how we could possibly do this a little simpler and break it down to where we can maybe even do this in our head. So at first looking at it, I'm thinking, how in the world can I break down 343 into something easy to work with? But I don't have to think about just breaking down the 343. I could break down the 21 as well. And that's really close to a multiple of 10, which would be 20. And then I just have one more group to make, because 343 21s is going to be the same thing as 21 groups of 343. Or sorry, I used the and there and it's not a decimal. So 343 groups of 21 or 21 groups of 343. So I'm going to leave that number the same, and I'll find 20 groups of 343, and then I'll find one group of 343. So immediately right off the bat we can see 343 times 1 is going to give us 343. And now we have that 343 groups of 20, or 20 groups of 343. Now, because it's a multiple of 10, I can kind of ignore 1 power of 10 for a moment, come back to it later. And now I can do 2 groups of 343, or 343 times 2. And that's a lot easier for me to do in my head. So I know 2 times 3 is 6, 2 times 4 is 8, 2 times 3 is 6, and now I can add in that power of 10. It is not just a 0, it is a power of 10. And then to find the product of 343 and 21, I'm going to have to add up both of these groups to figure out the total amount. So I do want to make sure that I line up my place values, so that I am adding values together. So my work does need to be written as neatly as possible and as organized as possible. 3 times 0 is 3. 0 plus 3 is 3. 6 plus 4 is 10. 1 plus 8 is 9. Plus 3 is 12. 1 plus 6 is 7. So my final answer is 7,203. If we were to put that into a model, we could use either one of these models. Notice that they did the same thing we did in this particular model here, because they broke up the 20 rather than breaking up the 343. Although you're more than welcome to break up the 343, in an area model, but so that you have all of those values together. So now we want to try to solve this with the standard algorithm next to the area model that we chose. So whichever one you drew in your journal, we want to go ahead and solve that with the standard algorithm right next to it. So standard algorithm, we're going to have 343 times 21. I'll start with my ones. 1 times 3 is 3. 1 times 4 is 4. 1 times 3 is 3. Now I'm going to change the color of the ink so that you can see in case you need a refresher on multiplication. But now we're going to go to the tens in our second factor. So we're not going to have any ones because we are dealing with tens. So we're going to go ahead and mark that place value with a 0. So when we add values at the end, we know we have 0 ones to add. So now we'll do 2 times 3 is 6. 2 times 4 is 8. 2 times 3 is 6. And we're going to add those values together. So 3 plus 0 is 3. 4 plus 6 is 10. 1 plus 3 is 4. Plus 8 is 12. And 1 plus 6 is 7. So, again, final answer is 7,203. That's what we had predicted with our estimation earlier, 7,203. So now we're ready to estimate, decide which model, and then solve with a standard algorithm to confirm our answer. So I'm going to look at this one, and I noticed that my 32 is really close to a multiple of 10. So I'm going to choose to use that one. I will use 231 groups of 30, and then I'll do 231 times 2 more groups so I can get my final answer. I'm going to ignore that power of 10 for a moment and take a look. So I'll have 3 times 1, 3 times 3, 3 times 2, and then I'll add in that 1 power of 10 at the end, not just a 0. Now I have 2 groups of 231. So I have 2 times 3 is 6, 2 times 2 is 4, and I can add those together. That's 2, 9, 13, and 7. So 7,392 should be what I'm looking for. Now I want to put this into a model. And remember, you can do each individual number and find your area model using that way, or you can use those larger groupings to break it down a little easier for you. And you don't have to draw quite so much. But we have 30 and 2 and 231. That's going to be the one I prefer, but you can do either. So if I take a look, I'll have 2 times 1, 2 times 3, 2 times 2. So my small box is 462, and that is the same as what I had up top. Then I can kind of ignore this power of 10 for a moment. And that's 3, 9, 6. And then I'll add in that power of 10, not just a 0. And that's what I had gotten originally as well. So now I want to confirm my answer using standard algorithm. 231 times 32. Start with my ones. So 2 times 1, 2 times 3, 2 times 4, 2 times 2 is 4. Now I'm moving to my tens. I'll mark that place. Remember, the only reason I change colors is so that you could see how I'm lining up my values. 3, 9, 6. I'll add those up. So we have 7,392. 7,392. Notice that since these numbers are the same and these numbers are the same, then my model is going to also show 7,392.